All right. If there's no homework questions, we'll go on and look at what we're talking about today and covering today. Now, what we're covering today isn't, I would say, is about on the same level as what we did yesterday. Because what we're going to be talking about today is addition, subtraction, and multiplication. So we're going to be doing addition, subtraction, and multiplication. Now, we're going to be doing it in two forms. We're going to do it vertically and horizontally. So we're going to do addition, subtraction, multiplication, vertically and horizontally. So this first one here, we'll look at addition first, vertically, up and down, and then horizontally. We good? So, yes. I'm actually late. Yes. I don't know about him. So, all right, guys. Yes, he was cleaning last night. He's going on the scoreboard. You don't know math. All right, guys. So, what we're going to do first is addition vertically. So when we add two things vertically, we're going to be adding them up and down. So the first thing we'll do is just write out the first part of the problem. Our first expression, 3x cubed plus 2x squared minus 7 minus x minus 7. Then we'll write the other expression right below it and match up the like terms. So x cubed would go under 3x cubed. Negative 10x squared would go under over 2x squared. We lined up the x squared. Do we have an x term? No. So we have two options. One is we could just leave it blank, or we could put plus 0x. We can just put something in its place to kind of take that spot. And then we would have plus 8. Then we're going to add our like terms. 3x cubed plus x cubed is 4x cubed. 2x squared plus negative 10x squared. Negative 8x squared. Negative x. Because negative x plus 0x would just be negative x. And lastly, negative 7 plus 8 is plus 1. That's it. Yes. Any other questions for this one here? Y'all get those, we should get some baseball pullovers. Now we're going to look at horizontally. Almost. So when we add them horizontally, we're going to use our parentheses. And we're going to put a plus sign in the middle because we're just adding them horizontally. Now for this here, because the sign in the middle is plus, it's really not going to change anything about the second set of parentheses when we multiply it by that positive. Can you just type that? Unfortunately, we can't, because the calculator requires that we have a value for x or y. Now the TI-89s can do this. There is programming that will let it actually add these two together. And part of the reason I don't cover it for that one is it's not allowed on any real standardized test except for the SAT. They let them, but it's a lot more steps to plug it in than just to do it. Now, because it is addition, we can go on and just drop the parentheses. We don't really need the plus. We can just say minus 5y squared plus y minus 4. And then we just need to combine our like terms. Now for this first one here, I'm just going to rewrite it with the like terms next to each other. Now 9y cubed doesn't have any like terms in the other equation or anywhere else in this problem, so it's just going to be by itself. 3y squared does have a like term, the negative 5y squared. The negative 2y and plus 1y are like terms, and our 1 and negative 4. So I just rewrote it where the like terms are next to each other. We don't have to do this step, because we could go on and just combine the like terms on the step above, from the step above, because 3y squared minus 5y squared is negative 2y squared. We have negative 2y plus y is negative y. And lastly, 1 minus 4 is negative 3. So we could have gone from the step up here where we dropped the parentheses straight to combining like terms. We didn't have to rearrange it. But if that is helpful, putting the like terms next to each other before combining it, do it. If not, you don't have to. Are there any questions with addition, horizontally or vertically? Do we need to see another example with addition? One more? With most of these here, I like having the vertical. It makes it easier to line everything up. So I'm going to look at another one vertically. And when we look at them vertically, we can say 2x cubed plus x squared minus 3x plus 4 is our first one that we have. And if there is any gaps like the one we had before in the second one here, we can just do plus 0x to fill in the gaps. Because if we look at the next one, well, we have x cubed plus 7x squared, but we don't have an x term, do we? So we can say plus 0x minus 2. In any spot where we have those gaps, we can do plus 0 times whatever the variable is. If it's x squared, we can say plus 0x squared or fill any of those in. Now what we're wanting to do is to add. 2x cubed plus x cubed is 3x cubed. X squared plus 7x squared is plus 8x squared. Negative 3x plus 0x is just negative 3x. And 4 plus negative 2 is plus 2. And that's it. And with either one of these here, horizontal or vertical, pick the one that you like best and do it that way. I'm not going to be a stickler on, well, it said to do it vertically. You need to do it vertically or horizontally. They're both getting to the same place. I'm not going to be a stickler about this here. Does that make sense? We'll see, depending on the number of students. Any questions on this here? How do we feel about addition horizontally and vertically? You feel good with this here? About on par with what we did yesterday? Subtraction is what we'll look at next, horizontally and vertically. So just like with addition, we'll start with the exact same thing. We're going to write out the two expressions over the top of each other. For subtraction, I think it's a little bit easier to keep track of our signs and have the correct signs if we do this vertically over horizontally. and we are subtracting. Now I put it with each of the individual terms going all the way across. The reason I do this is because it's easier to keep track of, and I also know with doing this long enough and seeing enough work, when we get further into it, having it just out front can sometimes we'll forget about it, especially once we get towards the end here and we're so focused on actually doing the operation, we forget that we're doing subtraction and just start adding. So it's a good way to remember what we're doing, and it's also good to keep track of some of our double negatives. So it's kind of nice to just go on and write the subtraction all the way through. Now we just need to subtract. So we can start off with the first terms, 2x cubed minus 8x cubed. Negative 6x cubed. 6x squared minus negative 3x squared. The negative and negative make a positive, which would give us 9x squared. Then we move on to the next one, negative x minus negative 2x. Well, the negative and negative would make a positive, which would give us plus x, because negative x plus 2x would be positive x. And lastly, 1 minus 9 is negative 8. And that would be our answer. Questions on this here? Are we ready for the next one? The next one we're going to look at is subtracting horizontally, so in a single line, which will be very similar to addition. Because we're going to start off by just rewriting our expressions with parentheses minus 2z squared plus 3z. So we're going to start off writing our expressions in parentheses with the subtraction sign in the middle. Now, just like with addition, the first set of parentheses, we can just drop them because it's not going to change the sign. But because it is subtracting, we're subtracting it from it. This negative is going to be applied to both of these here. We have to apply it to everything inside the other set of parentheses, which takes it from positive 2z squared to negative 2z squared, and positive 3z to negative 3z. It's going to change that sign because we're subtracting it from it. And this here is crucial, especially when we do this horizontally, to be applying this negative to everything in the second set of parentheses. Now, we didn't have to apply it in the first one, or in the last problem here. Well, essentially we did by when we subtracted each one of them. We made the other one negative, but we didn't have an actual step of making it negative because we were actually subtracting. Does that kind of make sense between the two? Now, we just need to combine our like terms. 3z squared minus 2z squared is going to be, well, z squared. Z minus 3z is negative 2z. Do we have any like terms with negative 4? No, so it's just minus 4. Any questions on this here? For addition, well, I'm going to pause. Any questions on this here? Okay. With addition, horizontal and vertical really doesn't make a big difference. Because no matter what we do with the parentheses, setting it up, we're just combining those like terms. We're just adding them. With subtraction, we've got to be careful with the signs. Because when we minus something, the signs end up taking away 3z minus 2z. Because if we don't apply that negative, it will change it. Now, with vertical, we really didn't have to worry too much about the sign change when we're multiplying through dropping those parentheses because of the subtraction and how it's set up. So this here, the way this is set up and works, removes a lot of the possibilities for error with sign errors that horizontal has. Any other questions with subtraction? Do we want to see another example of subtraction? We good, Caleb? Want to see? Okay. If we feel good with those, we'll move on to multiplication. Multiplying these vertically isn't something that's completely new to y'all. You've done vertical multiplication before. It's just been a while. It'd be doing something like this here, 12 times 13 or 13 times 12. Because if we multiply this vertically, these two numbers, well, we would do 3 times 2, which is 6, and then 3 times 1. Then what would we do next? Because we would put a 0, and then we would do 1 times 2. 1. And last but not least, we would add 6, 5, 1. We're going to do the exact same thing here if we're going to do this vertically. So if we do this vertically, we would start off with negative x squared plus 2x plus 4. And we're going to put it over x minus 3. And we're going to be multiplying these together. So we'll start off with the negative 3 and multiplying it through. So we'll do 3 times 4, which is negative 12. Negative 3 times 2x is negative 6x. And negative 3 times negative x squared would be 3x squared. So the big difference with this and our others using just two numbers is we do have multiple terms and addition, subtraction signs in the middle. So when we move over to the next term, well, we would start off with 0. We can do plus since it's positive. Anytime we have positive, we'll have to put the plus sign for it. Now we can do x times 4, which is 4x, and since it's positive, we'll put plus. Then we'll do x times 2x, which is 2x squared, and we would put plus since we have one more term. And x times negative x squared would be negative x cubed. And last but not least, we need to add straight down. Now with numbers, like we did in the previous one to get 156, well, we always start from the farthest right and move left. Because if we had, because it was 6 plus 0, but if any of those become greater than 10, we have to move the 1 over. Yes? Here, it really doesn't matter. Because is there any way that I could add negative 12 in a number and get something with x? Well, no. The only way I can do that is adding x. There's no way I can add two terms with x and get x squared, or add the x squared terms and get x cubed. We can't go over one way or the other. So for this here, the order in which we add or subtract really doesn't matter, but we can keep it going from the right to the left. Because we can do negative 12 plus 0, which is negative 12. Negative 6 plus 4x is negative 2x. 3x squared plus 2x squared is 5x squared. And then we have negative x cubed. And that would be our answer. Or we can go from the other direction and just say negative x cubed plus 5x squared minus 2x minus 12. Yes? Any questions on this here? Let's look at horizontally. I think horizontally is a little bit easier way to do multiplication of any two polynomials. Or it's the way that I like better. The first thing we're going to do is going to rewrite them with parentheses being multiplied together right next to each other. This is where we'll start out. And what we'll do from here is use the distributive property. We're just going to multiply through by each term. So the first one we'll multiply through by is with y. So we'll do y times 3y squared, which will be 3y cubed. Then we'll do y times negative 2y, which would be negative 2y squared. And y times 2 is plus 2y. And then we'll move on to the 5. 5 times 3y squared is plus 15y squared. 5 times negative 2y is negative 10y. And 5 times 2 is plus 10. I have a feeling y'all remember doing stuff similar to this here with two terms. Algebra 1. And last but not least, we need to combine our like terms. Well, 3y cubed doesn't have any like terms, so it'll stay the same. But negative 2y squared and 15y squared are like terms. So 15 minus 2 is plus 13y squared. Then we also have 2y and negative 10y. So 2y minus 10y is negative 8y. And then we have plus 10. And that's it. So if you like the vertical way to multiply better, do it that way. If you like horizontally, the way we just did better, do it that way. Pick which one you like better and do it that way. Any questions on this here? Do we need to see another example of this multiplication? We're good with this here. Let's look at 3, or example 4, multiplying 3 binomials. This here really isn't any different than what we just did. We just now have 3 terms, 3 things we're multiplying together instead of 2. And when we multiply more than 2 things together, the order in which we multiply them really doesn't matter. So if I wanted to, I could multiply those 2 together first. Or we could multiply those 2 together first. Or if we wanted to be a little bit weird, we could multiply this one and that one together and kind of jump over the middle one. But I'm just going to stick with going from left to right. I'm going to multiply the first 2 together. So we'll use our distributive property. And we can say x times x, which is x squared. Then we'll do x times 4, which is plus 4x. We'll do negative 1 times x, which is negative x, and negative 1 times 4, which is negative 4. Now at this point here, we would combine our like terms. So negative, or 4x minus x, which would be plus 3x minus 4. Because if we can simplify at any point along when we're doing our multiplication of more than one set of terms or polynomial expressions, it will be helpful because it will decrease the overall amount of numbers that we have. Now lastly, we need to do the distributive one more time. So we can start off with x squared and do x squared times x, which is x cubed. X squared times 5 is plus 5x squared. Now that we have that done, we can do the same thing with 3x. Well, 3x times x is going to be 3x squared. And 3x times 5 is going to be plus 15x. And then lastly, we can do the same thing with negative 4. Negative 4 times x is going to be negative 4x. And negative 4 times 5 is going to be negative 20. And lastly, we can combine our like terms, which will tell us that we have x cubed. Well, 5x squared plus 3x squared is going to be plus 8x squared. 15x minus 4x is going to be plus 11x. And then we would just have minus 20 because the negative 20 doesn't have any like terms with it. Any questions on anything we've done so far? All right. Almost. Do we need to see another example of multiplying 3 together? Now what we have here are some special properties or special product patterns that we can use. Because if we have, like the first one, sum and difference, if we have two monomials being multiplied together that are the exact same except for the fact that the sign in the middle is different, their product is going to end up being a squared minus b squared, the first term times itself, minus the second term times itself. And we also have these special patterns for squares and cubes. But really, if we write it out and go on and multiply it out, we'll get the exact same thing. It's not going to make that big of a difference. Like if we look at this one here, 4n plus 5 times 4n minus 5, well, we do have the same two numbers, just the sign in the middle is changed. So according to that pattern, what we could say is that the first term squared, well, 4n squared would be 16n squared, because 4 squared is 16, n squared is just n squared. Minus the second term squared, well, 5 squared is 25. So according to that shortcut, we could write it as this here. Now let's go on and work it out, because if we multiplied this out, well, 4n times 4n is 16n squared, because 4 times 4 would be 16, and n times n is n squared. Now 4n times negative 5 would be negative 20n. We would do the same thing with 5. 5 times 4n is plus 20n, and 5 times negative 5 is negative 25. Well, we do have two like terms, yes? The negative 20n and 20n. Well, negative 20n plus 20n is 0, leaving us with just 16n squared minus 25. We could get to the same thing. And the same thing holds true for the other two. We could go on and multiply them out, or we can use the shortcut. Because if we look at b, 9y minus 2 squared is the same as saying 9y minus 2 times 9y minus 2. It's multiplied by itself. We can't just square the first and second term and get to the correct answer, unfortunately. Here, we just need to multiply it out. 9y times 9y is 81y squared. 9y times negative 2 is negative 18y. Negative 2 times 9y is negative 18y. And negative 2 times negative 2 is plus 4. And the last thing we need to do is combine our like terms, and we get our answer. Now, according to the pattern, because they would call this A and B, is that this would be A squared minus 2AB plus B squared. Well, our A squared term, 9y squared, well, 9 squared is what? 81, and y squared would be y squared. Minus 2AB. Well, our A and B are 9y and 2, yes? Well, what is 9y times 2? It's 18y. And if we times it by 2, we get 36y. And 2 squared would give us 4. Guys, let's focus up here. And we would get to the same answer, or if we multiplied it out, we'd get there too. Any questions on any of this here? I won't linger on this too much, but this here is Pascal's triangle. It's the factor tree, because it helps us be able to factor products of the same thing if it's being multiplied by itself. And it works out that these are the numbers that correlate to it. Now, creating this is actually not that difficult, because once we start off, this is the base here, 1, 1, 1. Up here is what it'll always start out with. But from there, it kind of builds off of itself. Because 1 and 1 give us 2. And we can do the same thing. 2 and 1 give us 3, 2 and 1 give us 3. And here, 3 and 1, 4, 3 and 3, 6. And it actually works out, and we could actually keep building this beyond that. Because it gave us to the 5th power, 5th row would be the 5th power. We can go 6th, 7th, 8th for any power, and it would work out for factoring it. But that is all we are doing today.